what's going on with. They're making some changes, I guess. Okay. Now I would like to look at more examples. Okay, so we can choose something from 39 to 62. Find the inverse function. We don't need to look at 63 to 70. I would like to look at an example from 39 through 62. 1 or 2. 39 through 62. Okay, I'm going to look at 46. Let's choose 46. 46 has cosine inverse of cosine 7 pi over 6. Let's talk about this. Now, as we know, the inverse function of the function will give us what? Or the reverse. F of the inverse function will give us what? So when I apply the inverse function to the function, or when I apply the function to the inverse function, what do I have to get? Always and forever.
X.
Exactly x. So I am tempted to say, it's the inverse function of the function of 7 pi over 6. This is 7 pi over 6. And the answer is not so fast. Because it's true only if 7 pi over 6 is where it should be. If 7 pi over 6 for cosine and arc cosine and cosine, if it's not between 0 and pi, this is incorrect. And 7 times 30 degrees is 210, which will be here. So this is incorrect in this particular situation. Because, again, let me write it here for everyone to see, the angle has to be here. 7 pi over 6 is 210 degrees. This is the angle. So I can never write this. Can I still calculate? Of course. I will calculate this first. I cannot use the property of inverse functions and blindly write 7 pi over 6. It doesn't work. It's incorrect. No. I will determine this, and then I can apply cosine inverse to this number. So let's see how. So 7 pi over 6 is an angle in the third quadrant. Remember, it's pi over 6. Where's my table again? So if it's pi over 6, cosine is the square root of 3 over 2, but negative because it's in the third quadrant. So cosine inverse of cosine 7 pi over 6 is cosine inverse of negative the square root of 3 over 2. And now I need to determine an angle between 0 and pi, of course, because cosine is negative, it has to be in the second quadrant, whose cosine is the square root of 3 over 2 with minus. Well, all I have to do, because it still has to be over 6, all I have to do is go back up here and subtract pi over 6 from pi. How did I get 7 pi over 6? Adding pi over 6 to pi. So the angle will be pi minus pi over 6. 5 pi over 6. I wish I could have blindly copy 7 pi over 6, done. I can't, because 7 pi over 6 is not where it should be for cosine. I determine the cosine 7 pi over 6, which is here, which is negative the square root of 3 over 2, because cosine is negative here in the third quadrant. And then I ask myself, which angle in the second quadrant has cosine negative the square root of 3 over 2? Well, that has to be 5 pi over 6. Can you double check this with a calculator? Very easily. So we will enter cosine inverse, second cosine inverse, then we will copy cosine, and we will copy 7 pi over 7 pi divided by 6. Don't forget to close. Enter. It will not give me 5 pi over 6. The calculator is not that smart. I have to calculate 5 pi over 6, which I already have up here. We did something accidentally, the same thing. So it's right here. I don't have to calculate anything. Okay. Any questions? I didn't mean to do that. Any questions? Would you like to pick something else to work on? If not, we'll move on.
Can you do 39?
Of course, with pleasure, yes. So let's look at 39. Nothing works without practice, so I fully agree. That's why I always want my students to. You said 39, this one?
Yes.
Okay, 39. Any other? So we can copy it. Anyone else? Anyone else would like to choose another?
Could we do 55?
55, yes. I'm copying 55 as well. Good, good pick. Sine of sine inverse of 1/4. Perfect. Okay. So cosine inverse of cosine 5 pi over 5, 5 pi over 4 pi over 5. So the answer here, so careful, this is cosine, so this is a number, right? This is a number. I apply cosine to this number and get an angle. I would love to write 4 pi over 5. But is 4 pi over 5 where it should be? Where should it be? Let me copy the figure here. Because we're talking about cosine. If it's sine or sine inverse sine, then I have to look somewhere else. But because it's cosine, it has to be between 0 and pi. So I don't know what this is. 4 times 180 divided by 5. Lazy people use a calculator. So let's see what this is. 4 times 180 divided by 5. 144. It's under 180. Done. I don't have to do anything. So the answer is 4 pi over 5. For the next one, I would like to blindly write 1/4. As long as, so this is an angle, as long as sine of this angle is a number between -1 and 1. Well, it is. And this is it. There is nothing else I need to do. Any questions?
Could you explain that? Sorry. Could
Yes.
you explain that one more time,
This one or this one?
please? 55.
55. Very good. So
Yeah.
I applied the function. I apply the function to the function inverse. These two have to cancel their effect on each other. They disappear. Because this one cancels this one. This one cancels this one. So I copy 1/4. But remember, this is an angle. Sine applied to any angle has to be a number between -1 and 1. As long as this number is between -1 and 1, I'm safe, and that's the correct answer. If I have, for example, sine of sine inverse of 2, I'll say no way. Because there is no angle whose sine is 2. Sine and cosine are bounded functions. So I cannot write 2 here. You can say, why? They are canceling their effect on each other. Yes, but 2 is not a number between -1 and 1.
So it always has to be in between -1 and 1, right?
Yes. So one more time. Very good question. If sine is outside and sine inverse is inside, this number has to be between -1 and 1. If it's reversed, then it will be an angle. And the angle has to be between this and this for sine. Like here. Cosine is outside, so this is an angle. This angle has to be between 0 and pi. Sine is outside and sine inverse is inside. This number has to be between -1 and 1. The reverse, whatever the answer is, it has to be an angle this time. And the angle has to be between -pi/2 and pi/2.
All right, thank you.
Thank you. So let's take a look. Do we need to look at anything else? You wanna look at 51 or 52 or 53? Anything here?
53.
53, very good. So we have tangent inverse of tangent pi/2. Tangent inverse is outside, so the answer has to be an angle. If I blindly write pi/2, for tangent, the answer has to be anything from -pi/2 to pi/2 except -pi/2 and pi/2. Undefined. I cannot write pi/2. It's undefined. Okay, let's say one more and continue. Is there another one that you would like to work on? Let's look at 52. So I have sine inverse of sine of -3pi/4. And you can say, oh, this is easy. Sine inverse applied to sine, these two go away, and I write -3pi/4. Not so fast. I have to look. When it comes to sine inverse, we are looking at this. -3pi/4 is 2, 3, right here. This is -3pi/4. I'm sorry, 1, 2, 3, yes. -3pi/4? No, this is incorrect. Why is it incorrect? Because it's not between -pi/2 and pi/2. -3pi/4 is in the third quadrant. Can I still determine this? Yes, of course. But I cannot use the property of inverse functions. I cannot say that the inverse function of the function is x. The inverse function of the function of x is x. I cannot. Because it doesn't fall where it should. This answer is not between -pi/2 and pi/2 for sine inverse. So therefore, I will have to calculate the inside. So let's find first sine and -3pi/4, which is very easy. This is negative sine 3 pi over 4. 3 pi over 4 is here. I know this is very easy. It's the square root of 2 over 2, negative the square root of 2 over 2. Everything that is over 4. Pi over 4, a multiple of pi over 4. So then my problem changes into sine inverse of negative the square root of 2 over 2, because this is negative the square root of 2 over 2. And now I can find an angle, and it has to be in this fourth quadrant. Let me write it again here. It has to be in the fourth quadrant, because sine inverse of a negative number. So the angle has to be here, right in the middle. So this answer has to be negative pi over 4. It has to have the answer only where it's allowed. Sine inverse is allowed to have an answer only if I choose from negative pi over 2 to pi over 2. Not outside of that. Only here. And yes, you can check this with a calculator if you'd like to do that, so you don't miss any points and you're convinced. So this was sine inverse of sine, and it was of negative 3 pi over 4. It's not what I meant to write. Good. And it's not going to give us negative pi over 4. The calculator doesn't know that. But you will enter negative pi over 4 to check. And it has to be the same. If it's not the same, it's a mistake, and we have to go back. See? The answer is not blindly negative 3 pi over 4. Negative 3 pi over 4 is totally different. Is this. So you cannot, for this problem, you cannot blindly say, oh, I'm applying the inverse function to the function. The answer has to be negative 3 pi over 4. No, not in this case. You cannot apply the inverse function in this situation. The property of inverse functions in this situation. You have to calculate the middle and then find the sine inverse of your result. And you have to get this. I don't know what my computer is doing, but I hope it's not going to crash on me, whatever it's doing. Okay, back. Good. So I'd like to move on to 509. Good. So it's a continuation of the inverse functions. So let's see any problems that we would like to look at and see how this works. This is totally different, right? This time we are applying cotangent to sine inverse. Wow. Cosine inverse to sine. Tangent to sine inverse. In the previous set of problems, we had the function and its inverse. But now we don't. It's a combination of whatever. So let's choose from these whatever. Anyone would like to pick? If not, I will. Anything from 13 through 36.
Can we do 21?
Yes, let's start with 21. So this is in section 6.2. It's a continuation of what we're discussing, but now a more sophisticated situation. I think you said 21. Was it correct?
Yes, ma'am.
Okay, sorry, I was talking. Okay, cosine inverse of sine 5 pi over 4. These are not inverse functions, so I have to slowly take it one by one. I have to determine this and then apply cosine inverse to it. There is no way I can simplify anything here. Here I was able to whenever I could, because the functions were inverses of each other. Inverses of each other, inverses of each other, inverses of each other. But now this is slightly different, so we have to do it one by one. So allow me to stop this.